Hi, in this video we will learn about friction. Friction is a necessary evil. Without friction we cannot walk, we cannot hold the things, we cannot survive without friction. At the same time, friction results loss of energy in the form of heat. Let us know much more things about friction. I am Mallikarjun from Hyderabad, India. Welcome to my channel Elite Academy.
Consider a block resting on horizontal surface. The weight of the block W acts vertically downwards. The normal reaction N acts in the upward direction. So here let us apply a horizontal force P parallel to the horizontal surface. Then the frictional force acts in the opposite direction of applied force. If P is acting towards right side, then the friction F acts towards left side. Under equilibrium, N is equal to W. That is, upward force is equal to downward force. And if the body is at rest, then the applied force P and the frictional force F are equal and opposite. Suppose if we increase P is equal to 1 Newton, then friction also becomes 1 Newton. If we apply force 2 Newtons, then friction also becomes 2 Newtons. In this way, as P increases, F also increases. This will continue up to certain limit. The maximum value of frictional force is called limiting value of static friction, which is given by Fs is equal to mu s into n, where mu s is coefficient of friction. If applied force P is less than this limiting value Fs, then the friction F is equal to P. Applied force is equal to friction. In this case, the body is at rest. Whereas when P is greater than Fs, then body moves. The friction cannot increase beyond Fs. Therefore, the friction is still F is equal to Fs. That's all. Let us consider a block resting on inclined plane. The angle of inclination of the plane is theta. In this case, the weight of the block W acts vertically downwards, and the normal reaction N always acts perpendicular to the surface. Here the surface is inclined, so normal reaction N acts perpendicular to the inclined plane. Let us resolve W into two components, W cos theta and W sin theta. The component W cos theta balances the normal reaction, whereas the component W sin theta tends to slide down the block. When the block tends to slide down, the friction acts up the plane. So when the body is at rest, this normal reaction N is equal to W cos theta. This is always in equilibrium. But if the body, where we are taking x-axis as parallel to the inclined plane and y-axis perpendicular to the inclined plane. In case of y-axis equilibrium, N is equal to W cos theta. And in case of x direction equilibrium, we have F is equal to W sin theta. Then the body remains at rest. If W sin theta is greater than Fs, here Fs is limiting value of static friction. Friction cannot increase beyond Fs, where Fs is equal to mu into N, where mu is coefficient of friction. In this case, the body slides down because down the plane force is more than frictional force. Therefore, the body slides. Let P1 is equal to force applied to stop the block sliding down. Let us apply the force P1 parallel to the inclined surface in the upward direction. Let P1 is applied parallel to the inclined plane. In this case, for vertical equilibrium, N is equal to W cos theta. When the body tends to slide down, then the friction always opposes the motion. Therefore, friction F acts along up the plane. Here, F is given by mu N, but N is W cos theta. Therefore, F is equal to mu W cos theta. So, under equilibrium, P plus F, they are acting up the plane. So, P plus F is equal to W sin theta. Here, P1 is the force applied. So, P1 is equal to W sin theta minus F. But F is equal to mu W cos theta. Therefore, P1 is equal to W sin theta minus mu W cos theta. We can take W common. So, we get P1 is equal to W into sin theta minus mu cos theta. This much of force required to stop the block sliding down the inclined plane. Let P2 is force applied to move the block up. Let us apply force P2 parallel to the inclined plane along up the plane. When the block tends to move upwards, then the friction acts in the opposite direction down the plane. So F is acting down the plane in the opposite direction of P2. For vertical equilibrium, the normal reaction N is equal to W cos theta. The frictional force F is equal to mu N, but N is W cos theta. Therefore, F is equal to mu W cos theta. For equilibrium along x direction, we have P2 is equal to friction F plus W sin theta. But F is mu W cos theta. Therefore, we have P2 is equal to mu W cos theta plus W sin theta. We can take W common. So, if we take W common, P2 is equal to mu cos theta plus sin theta. This much is force required to move the block up the plane. For classroom classes and online coaching, you can contact me. My mail ID is eliteacademyhyd@gmail.com.
Please subscribe my channel and hit the bell icon for latest updates.